Okay students, let us try to solve this numerical. The question is, a photon of wavelength 4 into 10 to the power of minus 7 meters it is, strikes on metal surface, the work function of metal being 2.13 electron volt. Okay, you are being given work function which is nothing but h nu naught is the work function, which is 2.13 electron volt given to you. Now you need to calculate energy of photon in electron volt. Fine. So let us try to solve this first one. We know that energy of the photon is given by a formula which is E is equal to h nu, or h is equal to c by lambda. So we'll see that we put up the values for energy will be equal to, h value is a constant value 6.626 into 10 to the power of minus 34 joule sec, and you have velocity of light 3 into 10 to the power of 8 meter per second, and the value of lambda, that is wavelength, is given to us as 4 into 10 to the power of minus 7 meters. Let us see that we multiply first 6.626 with 3 and you get back 19.878, and we add the powers of 10 in the numerator first. So we are having 10 to the power of 8. So we multiply and then we get back this as 19.878 into 10 to the power of minus 26 here. So now let us see that you are dividing 19.878 by 4, where you will get 4.9695 into 10 to the power of minus 26, and 7 you cut off, you get back minus 19 joules. So this is the energy of a photon which you are getting. But this energy which you are getting is in joules. How? Just have a look. This meter and this meter got cancelled. This second and this second got cancelled. So you are left over with joule. But the question is, you need to find out that energy of photon in electron volt. Fine. Now here you can see that a relation is given between electron volt and joule to you. So we will convert this particular joules into electron volt, right? Energy in electron volt. We know that 1.602 into 10 to the power of minus 19 joules is 1 electron volt. Therefore, your energy above in the joules is 4.9695 into 10 to the power of minus 19 joules will be equal to how many electron volt. We will just see to it that 4.9695 into 10 to the power of minus 19 joules, we divide it with 1.602 into 10 to the power of minus 19 joules. So you will here have 10 to the power of 19 will get cancelled off. You will have answer as 3.10 electron volt as the answer in terms of the energy in terms of electron volt. So that was your first energy of photon in electron volt done. Now the second thing which you need to find out here is the kinetic energy of the emission. So let us continue. We need to find out the kinetic energy of emission. Now kinetic energy we know is half mv square, and that kinetic energy of emission, half mv square, can be written as h nu minus h nu naught. Now here this h nu we can take it as the photon energy. This is photon energy, and this is your work function. You can see that value of work function is given to us in the question. Okay, so let us try to solve this. Photon energy, we have just now above found out this one, 3.10 electron volt is the photon energy, minus work function, if you will see in the question here, is given to you as, here you can see 2.13 electron volt. So we will write 2.13 electron volt. That's it. You get back the energy as 0.97 electron volt. So this is your kinetic energy of emission. Second part is done. Now let us have a look at the third part, that is the velocity of photoelectron. You need to find out. We need to find out velocity. Okay, so let us try to find out the velocity of the electron. Now we know the formula as kinetic energy is equal to half mv square. From here we need to find out the velocity. So v square will be equal to 2 into kinetic energy divided by m, or further it can be v will be equal to root of 2 into kinetic energy divided by m. So let us try to put the values of kinetic energy and m. Now here kinetic energy we are already aware, you are having 0.97, but that is in electron volt. Fine. So here first let us try to, here kinetic energy is 0.97 electron volt. Let us first convert that into joules. So we know the relation between joules and electron volt, which is given to as 1 electron volt here is 1.602 into 10 to the power of 9 minus 19 joules. So how many 0.97 electron volt will be in joules? So you just multiply with the value 1.602 into 10 to the power of minus 19. So kinetic energy comes out to be 1.55 into 10 to the power of minus 19 joules. And here the mass of electron is given to you as 9.11 into 10 to the power of minus 31 kg. Rather we know the mass of electron here is this. So now let us try to put the value of kinetic energy, which is this value to be put up here. So let us put this value in terms of joules itself. So that will be 1.55 into 10 to the power of minus 19 joules. And you have mass 9.11 into 10 to the power of minus 31 kg. So now velocity will be root of 2 into 1.55 you will get 3.1 into 10 to the power of 19. You can cancel it with 10 to the power of 31. So you will get here 10 to the power of 12. Okay, in the numerator. And here you have divided by 9.11. And for the units you have joules and you have kg inverse, which I have taken in the numerator. So on finding out the root value for this, you divide 3.1 divided by 9.11, you will get 0.34 into 10 to the power of 12 joule per kg. Now here root of okay, before finding out the root, let me tell you that 1 joule is nothing but equal to kg meter square per second square, right? So if I write over here for joule kg meter square per second square dot this kg inverse, and this get cancelled off, so you are left over with meter square and second square. Now let us try to find out the root of this. So 0.34's root will be 0.583 and 10 to the power of 12 will be giving you root 6, and meter square per second square will be giving you meter per second. Therefore, finally the velocity will be 5.8 into 10 to the power of 5 meter per second. So this is how this numerical is to be done. You can just have a glance once for the whole numerical. It's about the photon of wavelength which strikes on the metal surface with some work function of the metal being 2.13 electron volt, followed by 3 questions. I hope stepwise all the steps are clear to you and you have understood the numerical. Thank you all.